Hi everybody, Mrs. Danielson here, and today we're going to combine two things we've worked on before and combine them, and that's reference angles and your 6 trig functions. Let's combine those into one thing, and that's what we're going to do on today. Let's go ahead and let's get going. We're going to switch over here to my iPad and get started on that. So let's start by talking about our triangle. We were working on it before. We just had it kind of wherever we wanted it to be, right? We had our 3 sides. We had our hypotenuse, our opposite side, and our adjacent side. Today what we're going to do is we're going to take that triangle and we're just going to put it on our coordinate plane in a standard position. Standard position again means that it's starting here at the positive x-axis, okay? And then we're going to have our triangle here on the positive x-axis standard position. So now your adjacent side is going to be your x, right? So our angle is right here. Adjacent is x, opposite is your y. And your hypotenuse, we're going to call r. So all we've done is we've taken that triangle and we've just planted it down on our coordinate grid so that it's in a standard position with an x and a y and an r. Okay, other than that, it's still that right triangle we've been working with, but now instead of opposite and adjacent and hypotenuse, we're going to call it x and y and r, right? So if we talked about sine of our angle, instead of opposite over hypotenuse, we would now call it y and r, right? And for cosine, instead of adjacent and hypotenuse, it would now be, an x and an r. And your tangent, instead of being opposite over adjacent, it would now be a y and an x, right? So we're just changing our letters, basically, that's all, and just putting it down in terms of our coordinate plane, okay? What would cosecant be? Right, it's just the reciprocal of sine, so it'd be r over y. Secant would be r over x. Cotangent would be x over y. Okay, we do have a couple rules, things we need to think about when we look at this, right? We have some things that cannot be 0 because they're in the denominator of those fractions. For instance, on tangent, x cannot be 0 because that would be undefined. And over here at cosecant, y cannot be 0 because that would be undefined. Secant, x cannot be 0. And for cotangent, y cannot be 0, right? So what that means is, for instance, if I had the angle 90 degrees and I want to take the tangent of 90 degrees, right? So I'm looking right here. This is my angle. Okay, tangent is y over x, right? So my x for that angle is 0, right? So that's y over x. My x is 0 at that angle. So this would be undefined, okay, because there's no x at that angle. So you kind of have to keep an eye open for those things, right? For some of these angles, particularly ones at 0 degrees, 90 degrees, 180 degrees, and 270 degrees. Okay, now we do have signs of our trig functions that we can watch out for. We're going to be using these in just a second. Signs of the trig functions, and a little way to help us remember them. Okay, in quadrant 1, okay, all of your trig functions are positive. In quadrant 1, they're all positive, everything, all 6. In quadrant 2, okay, sine is positive and cosecant, it's reciprocal. Just those two. The other four are all negative. In quadrant 3, tangent and cotangent, so tangent and it's reciprocal, are positive. Everything else is negative. And for quadrant 4, cosine and secant are positive. Everything else is negative. Now, to help us remember that, like how do you remember that, right? We have a little thing to help us. So if this was our coordinates here, right? This is 1, 2, 3, and 4. Okay, this one would be all A sine and its reciprocal cosecant. Tangent and its reciprocal, and cosine and its reciprocal. Remember, we go this direction, all sine, cosine. Okay, now if you just look at those first few letters, I'm going to change the color here just to help us make it stand out a little bit. This would be A, S, T. I accidentally erased my O there. Okay, so that would be all students take calculus. All students take calculus. Okay, quadrant 1, A, all students. Quadrant 2, students for sine. Quadrant 3, take tangent. Quadrant 4, calculus, cosine. That helps you remember which trig functions are positive in which quadrant. Okay, anything else in that quadrant is negative. So if you're in tangent, in your quadrant 3, and you're doing cosine, it's negative. The only thing positive in quadrant 3 is tangent and cotangent. Anything else is negative. Okay, these are the trig functions that are positive in that quadrant. Okay, everything else is negative. Why do we care about this, right? Why am I even telling you? Okay, here's the reason why. What we're going to do is we're going to take an angle and then find its reference angle, and then that'll tell us what the trig function is. Okay, so we're going to go back to reference angles. Okay, so if I have an angle like this one, let's say it's 45 degrees. Something small, it's in quadrant 1. Okay, then its reference angle is whatever angle is closest to the x-axis. So in this case, it would just be its angle. It's the closest to the x-axis. But let's say instead, I'm doing this angle over here. Let's say that one is 135 degrees. Okay, the reference angle is whatever angle gets me to the x-axis the fastest, which is closest. And in this case, it would be this one. That angle is closer to the x-axis than 135, right? This one would be 45 degrees. That's the reference angle. Let me write that a little bit clearer. I'm trying to squish it in there. Reference angle. The angle that gets you to the x-axis, right? If I came back over here and I said that was 45 degrees, then the 45-degree angle is also the reference angle. It's closest to the x-axis. Okay, let's say, do another one. Let's say I'm right down here. Let's say my angle is 210 degrees. My reference angle is the angle that gets me to the x-axis. In this case, this one. What is that angle that gets me to the x-axis? Right? It's the difference between 180 and 210, or 30 degrees. And that's my reference angle. Right? Whatever angle gets me to the x-axis, the closest one. Right? Let's do one more. And then we'll put this together into why I'm even talking about this stuff today. All right, so let's say, do one more down here. Okay, let's say we have, let's say we have 345 degrees. Why not? Okay. Your reference angle is the angle that gets you to the x-axis, the closest one, which is going to be this one. Okay, which is the difference between 360 and 345, which is 15. That's not drawn to scale, right? But 15 degrees would be your reference angle. Okay, whatever gets you to the x-axis. Okay, so now we know how to find a reference angle. Let's put this stuff together. So let's say we want to find the sine of 240 degrees. Okay, I don't know what the sine of 240 degrees is, but what's the reference angle for 240 degrees? Okay, 240 degrees is down here in quadrant 3, right? 240 degrees. So the reference angle is what? What's the angle that gets me to the x-axis? Right? That would be 60 degrees. So what is the sine of 60 degrees? Right? And for that, we can go back to that table we used a few lessons ago, right? The sine of 60 degrees, which is the square root of 3 over 2. Again, we got that from our previous lessons. Okay, but we're in quadrant 3, and is sine positive or negative in quadrant 3? All students take calculus. Okay, this is sine, it's not tangent, so that means it's negative. And so your answer is negative square root of 3 over 2. Okay, so we're finding the reference angle that gives us the answer of our trig function. And then we figure out from all students take calculus what the sine is. Okay, let's do another one. Let's do cotangent of 495 degrees. That is a very large angle. Okay, let's draw our little XY here. Okay, what quadrant is 495 degrees in? Right? Well, we know we go all the way around one time, right? That's 360. That leaves us with 135 degrees, right? So we're going to go all the way over here into quadrant 2. That's 495 degrees. Okay, what's the reference angle then? What angle is going to get me to the x-axis the quickest and shortest distance? Right here, what is that reference angle? Right, the difference between what the difference was here between the x-axis and that one. This was 360, so this was 135. So that means my reference angle here is 45 degrees. So what I want is the cotangent of 45 degrees, right, in quadrant 2. Okay, the cotangent of 45 degrees is 1, right? And is cotangent positive or negative in quadrant 2? All students take Calculus, oh, sine is positive in quadrant 2, not cotangent. So that means it's negative. Okay, let's see, let's give you one more. You guys can do this one on your own. I'll have you pause the video while you work on it. This one's gonna be in radians instead of degrees. Let's say we wanna know, let's do the secant of negative pi over 4. Okay, you want the secant of negative pi over 4. I want you to pause the video and see if you can figure this one out on your own. When you get an answer, then push play. Okay, got an answer? Let's see if we have the same one. Okay, so let's write what the angle is first. What we're trying to solve is a secant of negative pi over 4. Negative pi over 4, right, is an angle that's going to go clockwise instead of counterclockwise. Right? It's 45 degrees in the negative direction, so we're right here. So what's the reference angle for that? It's the angle that gets us to the x-axis, which is this one. It's the same thing, pi over 4. So we want the secant of pi over 4. All right, the secant of pi over 4, right? We can get that off of that grid or that sheet we got from the other day when we did all 6 trig functions, right, for the 3 main angles. And it was square root of 2 over 2. Okay, and then for the sine, all students take calculus. Okay, is secant positive or negative in quadrant 4? Well, secant is the reciprocal of cosine, right? This is cosine and secant. So it's positive in quadrant 4. So this is your answer. Okay, did you get the square root of 2 over 2? I hope so. All right, thanks everybody. That's what we're working on today. Go to your practice problems, and everyone have a good day.